We are going to figure out how to calculate arc length using polar coordinates. So I'm going to do it with an example, but before I do that, let me give you the formula, the derivation of which is in your book. The arc length of a curve that goes with theta going from A to B is integral A to B square root of r squared plus dr d theta squared, so itself plus its derivative in a square root for an angle from A to B. So that's fairly easy to remember. If you cannot remember, try to derive it on the spot when somebody asks you. Let's say the length, we are looking for the length of chordoid, this one, given by r equals 1 plus sine theta. You have to figure these out on your own with tables. It goes from 0 to 2 pi. It's pretty obvious. Here's the formula. If you do it by hand, you get this, and you can use methods to figure it out. But let me do it with my graphic calculator. So I know that r equals 1 plus sine theta, so I will enter that 1 plus sine theta. I can either take this by hand and then deal with this formula directly, or let your calculator figure out the derivative for you. I'm going to do it both ways. First time I did this, I said, okay, well, I'm going to use this formula that I developed by hand. But this time I'm going, okay, I'm even lazier, so I want the calculator to calculate the derivative. So once you have the R2, you can let your calculator get the derivative. How? You can go to math and go down, and that's built into your calculator. You might as well use it. And derivative. Do you see that? The way you enter that is, well, derivative of what? R1. So you have to get R1 from variable y bar and make sure you go to polar. And here's your R1. To select it, you have to hit enter. Then comma, theta. Okay? Derivative with respect to theta. You want that be given in as a function of theta. So you enter theta twice. Okay, so I put R1 itself. R2 is the derivative, so I didn't even calculate the derivative. So let's go to home screen. So I'm going to enter now the integral. Where is the integral? Right here. You go here, scroll down, the math menu. Where the derivative is, you have the integral right there. Alright, so I'm going to go, that's going to be the square root. And here's my square root. Okay, square root of what? R1 squared. Instead of entering this formula, I can do it this way or I can do it this way. This is a little bit even easier. R1, where am I going to get that? From the variable menu. Go to y bar and go to polar. And pick the R1 up from there and square it. Here we go. Plus. Now R2, same way. Go to variables, y variables, go to polar, and pick up the R2. Very nice. That's the derivative. Square it. Here we go. And then I take the square root. Okay, so this is equivalent to that. Then comma what? Theta. Everything is with respect to theta. So I get theta from here because I'm already set in polar. Then it's going to go from, these are the limits of theta, it's going to go from 0 to 2 pi. Here's my 0, comma, 2 pi is 2 pi. You don't even have to figure it out. Just enter this pi, close your parentheses, make sure that number of left and right parentheses match. It looks pretty good. And push enter. It's thinking. It's a good sign it didn't give me error. 7.9999 because it's doing it numerically. Here I just hit 8.0, so it depends on the method your calculator uses, but nevertheless it is 8. Alright, and so you can start using some shortcuts, and I really like that R1, R2, R3, or X1, X2, X3, those kind of things. You don't have to re-enter them. Once you enter it in your equation editor here and have the right modes, that prevents you from re-entering all the formulas. If your teacher lets you use a graphic calculator, this is a great tool to check your work with.